Hi guys, welcome to Learn Electronics Repair. I've mentioned a few times that I thought one of the areas of electronic repair that is worth getting into, because I'm sure it's going to grow massively, was e-bike and e-scooter repair. So this came from one of the local hire shops who hires out and sells bikes and scooters, yeah? And it's the first time I've actually been asked to repair one of these things. So this is a battery off an e-bike, and we have the charger here. Now, the battery itself is functioning. Again, this one's charged, but the charger doesn't actually work. So the charger will not charge the battery, okay? That's the fault on it. So, as I say, I've been asked to repair this. Let's have a look. Let's see what's inside it, how easy it is to even get into this thing. And let's see if we can fix it, yeah? As I've said, I've never looked at one of these things before. It has 4 terminals, one's longer than the others. So I think that makes contact first. Obviously minus plus. I don't know if they're in parallel or if there's some sort of sensor on here. We can have a quick look. Obviously, if we open this up, we might know a bit more anyway. But ground. Meter's working. Let's just go to the positive. Does that connect to these? Nope. And these middle two, do they connect to each other? No. So there are 4 connections going to the battery. There might be screws down here. Oh, and probably one there as well by the loops of it. Yeah, these are like some sort of hex type thing. Not hex, the star type ones, which has like a pin in the middle by the loops of it. Yeah, just get the focus down there. Yeah, we can see it. Okay. So first of all, do I have a suitable screwdriver type bit to get on that? Okay. So Torx, these things are called. I remember now. Torx. I had quite a few like these magnetic type screwdriver sets. None of them had the right size bit, and if they did, they were not narrow enough to get down there. Okay, I had a set like this, but the smallest one is too big. Eventually, this trusty old one, I probably had this for 20 years or something, this actually did it. Okay, so this just goes to show why you need a lot of these tools. Hopefully there are not 2 hidden ones under here. Let's see if this will actually come apart. And no, even now I'm not into this thing. That unplugs at least. So we either do have 2 hidden ones here, or we'll just have to crack this open. Let's see. A little bit destructive, but we'll try. See if it'll even move. No, not easily. If these are hidden ones, we should be able to get this top bit off. Doesn't seem to be the case. I don't feel anything under here. We'll have to try. This is not very heavy, but yeah, try this technique. So it seems to be, yes, it's opened. So that did the job. Okay, this side the same, towards the corner. Okay, so I don't think, yeah, no hidden screws, just clipped on tightly basically. Okay, we're in. Well, I do notice that actually is an LED. You can see from there. Okay, yeah, that's there. Okay, I won't just power up now to see if that lights up, because probably I'll just end up with a dangerously high voltage in the capacitors if this is not running. Looks like yeah, we have to unsolder these 2 little metal tags here, and then we can take this cover off. Okay, First things first, is there any nasty voltages in it? So we have one large capacitor here. The connections are at this end. I would be very surprised. I'd rather be very surprised by reading the voltage than being very surprised by putting my finger on it, by the way. Okay, so let's check. No, there's no voltage in there. I say it's been sitting here for about a week anyway, so I don't know how long before that it was faulty. Okay, so we have it. Let's check while we're looking at this first. A few basic checks. So first of all, we have a fuse, so we should check the fuse. That's the first one. And the fuse is intact. So there's probably no short circuits anywhere on here. At least not on the high voltage side, okay? We then have the various mains filters. Here's the bridge rectifier. There's no PFC on this, I don't see it. A couple of switching transistors. A couple more of these filter capacitors. Yeah, filter capacitors. I see another couple of diodes down here. Okay, something else like a transistor here. Yeah, this is the main transformer. So there's an inductor here. This could be a PFC circuit actually, if that's the PFC inductor and this is the PFC transistor, but you'd expect it to be a MOSFET. Could be a standby supply. Let's have a look, see if we can just figure out what we have. So mains comes in here. This goes through the fuse. And then kind of down this way through these various inductors. It will end up on the bridge rectifier on one of the AC. That one. Okay, so that's power coming in and this is the other power coming in. So we have continuity as far as the bridge rectifier. We now have the positive and negative out of the bridge. So we can see a chamfered edge. This is the positive. If this has no PFC, then this will go to the positive end of the large capacitor. And it doesn't, but it goes... Is that a diode? Yeah, via a diode. So this has PFC. This is the negative end and that will go to there. Okay, so from the positive end of the bridge to the positive end of the large capacitor, I see a diode. That tells me I have a PFC power supply. So basically a circuit like this, we have the bridge rectifier. We know everything's okay up to here from the AC coming in through the fuse and the filters. Plus minus, this goes to the negative end of the large capacitor. And to the positive end we see a diode. Okay, like so. And that tells me we have a PFC circuit. So here we have a inductor coil and here we have a MOSFET. Okay. From your PFC controller. So we're going to have a circuit like that. And that's why I see a diode from there to there. Okay. And reading about 0.4. So that's like a fast switching diode. And that reads okay. We would then expect to have about 380 volts on here. This is switching at very high frequency. And that inductor, I think we can say is this one. Okay. The diode is probably one of these. Let's have a look. There's two. I mean, there could be two in parallel. Yeah, look, they're in parallel. You can see they're in parallel, okay? So that's the diode that I can see. There to there. Two diodes in parallel, okay? So this will be the inductor for the PFC. And we know that that reads okay. Then the MOSFET, it's normally a MOSFET, but this looks like a transistor. See something or other. Let's have a look. There's some more devices here. 14NM50, that's a MOSFET. 15NM65, the two different ones. Interesting. Okay. Two different port numbers. Interesting. And this one looks like a 2SC. That looks like a bipolar. Okay, so let's see. The inductors here, we can see the connection from there to there. There, in fact, actually, that goes to our two diodes in parallel, and we know this one goes to the positive end of the large capacitor. There, which is the positive side. Okay, positive. And then from that point, we should go to usually a MOSFET, and I can see it goes here. This is the gate, drain, source would go to hot ground, which is the negative end of the bridge. Yes, it does. So that MOSFET is the PFC. Okay, the other one is something else. That one looks like it would go, let's think. If it was switching the main transformer, it would go to the positive end of the capacitor. Yes. And then it would go to the transformer. Primary somewhere. Goes down here. Yeah, it goes there. Goes there. So that was like the transformer primary. Yeah, probably. So that is your switching MOSFET for your power supply. This is your switching MOSFET for your PFC. And then this one here, where's that connecting? And this is just to familiarise myself, so I've got a good idea of what I have here, okay? So as bipolar transistor, base, collector, emitter, it looks good. This doesn't go to hot ground, won't go to the positive, might go to the positive of the capacitor. No, so that is not connected directly to the high voltage. This might be to do with the startup circuit for the controller chip. Okay, controller chip is that one. Let's hope we can read the markings. And then on the output, all we're really interested to know is, do we have a short? So opto isolator, these are the output diodes that'll set the voltage, no doubt, or some sort of current limit. Okay, do we have a short? So we have 4 wires. The thick ones are obviously the main power, and we don't have a short there. 59k, and then these are going to be some sort of sense or some sort of low voltage supply. I'm not sure, probably some sort of sensing. I don't know what type of batteries these are, to be honest. Okay, so we have an idea at least of what we're looking at. Not totally sure what this is doing, but I'd imagine it's probably to do with the power for this, at least the initial startup, or the auxiliary winding. So this chip will have some sort of circuit to start it running, and then there will be an auxiliary winding on the transformer, a secondary, which feeds back into here to keep it running. And that might be to the voltage regulation on there, maybe. Just guessing. Now, what sort of chip do we have? And the question is, I'm really not sure what we have at all. Oh, well, I know what's wrong with it. That's what's wrong with it. The chip has blown the top off, yeah. The question is, what the hell is this thing? Yeah, what is it? What was it? Yeah. Will the microscope help? Well, I can't see any markings on it at all, unfortunately. I'm just trying to move the lighting around a little bit. No, can't see anything. Let's try the USB. Okay, so I definitely don't see any markings. What do we know? Well, we know it's a 16-pin chip. We know, I think we know, it's a combined PFC and pulse width modulator controller, because I don't see any other chips here, and we know this has PFC, and we know it has pulse width modulation for the power supply. There are no chips on the other side, so therefore this must be doing both. Okay, so we know that. So we have a 16-pin combined PFC and PWM chip. See, so this is that transistor, the 2SC, whatever it was, 2SC3852. Okay, bipolar NPN. This is the base collector emitter. See, so base goes here. That's a diode or a Zener diode. Yeah, it says DZ3. So this must be a Zener diode connecting to the base. So therefore, this is used as a voltage regulator, a series regulator. That's why we have a Zener here, sets the output voltage, which will be on the emitter if it's an NPN, which it is, I think. Yeah, NPN. Okay, so we know that. So let's see. So this is the base, which is here. So the base goes to the Zener, and then the other end of the Zener goes, yeah, this is the capacitor, okay, which is that one. So the negative end of the capacitor, what is this rated at? 63 volt, 47 microfarad, okay. So negative end of the capacitors go into the anode of the Zener diode, and then the cathode is going to a resistor back to the positive of here. Is that where it goes? Yeah, so effectively 27k resistor feeds the Zener, and then the other end of the Zener goes to ground, and then this puts a voltage on the base. So this is an emitter follower. So this end, I would think, it goes to this diode, and then that end, I would think, goes to the transformer winding somewhere. I'm looking for the auxiliary. Okay, not directly. Which way is this diode? Yeah, that way I expect it to be, to the collector. So I would have thought that this comes from an auxiliary winding on the transformer somewhere, although I don't actually see it. Okay, that's where I would have thought it would go. But the upshot of this then is the emitter of this would go to, I would think, the supply pin on this chip. And then we know where VCC is. I'm hoping that's the case. pin 1. So pin 1 appears to be VCC. Okay, so we know a bit more about our chip. We know it's 16 pin. We know VCC is on pin 1. Okay, where's ground? So ground I would have thought is the same as the negative end of this capacitor, which I would also think is the same as the negative end of the large capacitor. There. Okay, and that would go to ground on our chip. But it goes to pin 6. It goes to pin 2. Pin 2, pin 6. Okay, so pin 2 and pin 6 seem to go to ground. Okay, so our unknown chip. We know SOIC 16, that's the package, okay? So 1, 2, 3, 4, 5, 6, 7, 8. This appears to be VCC. Okay. This appears to go to, well, it does, it goes to ground, and so does that one. What else can we find? I'm sure we can find out where it's driving the gate of the pulse width modulation for the power supply, and also the gate of the MOSFET, which is on the PFC. So we know this is a combined PFC and PWM. That's what the chip is. Okay. See if we can figure out where that's connected to, and then maybe we can figure out what this thing actually is. Okay, so these two. So gate and gate towards here. So this is one of the gate pins. Where's it going? Well, it goes along this way, it goes around here, all the way down here, disappears into some sort of via. Does it go to the chip? It may not go directly, but maybe through a fairly low value resistor. Let's have a look. Well, we know that's VCC. 50k, 5 meg, 50k, 50k. All reading 50k. What about this side? $50 ohms. That looks like it might be it. There, 50 ohms, and then 50k, 50, 60k. Okay, so that appears to be where it goes to via a 50 ohm resistor, which is on pin 13. Okay, and that goes to this one, and we know this one is the MOSFET for the main power supply, because we know that one is a PFC. So pin 13 drives that. Okay, so that is PWM. Then where's the one that's driving the PFC? Okay, so this is our PFC MOSFET. I bet it's down this side again. Let's have a look. $22 ohms to pin 12. Okay. And that's the only one it goes to. So, our mystery chip now, PFC, via 50 ohms and via 22 ohms, which are standard resistor values. That looks good. So, that's what we know about our chip. Now, this is where it becomes a bit subjective, because you've got to kind of figure out what it is. A bit of Google searching might help. I have one in mind, which is SG3525A. That's just because I've seen this chip a number of times, and I think that is a combined PWM and PFC, but I don't know for certain. Let's have a look. Yeah, it's not that one, because this is not a combined controller for the PWM and PFC. Okay, so that ain't it. Let's do some general searching. So, combined PFC PWM controller. Okay. Well, we have a few options there. I mean, we're just on one manufacturer at the moment, so, you know. Well, this has PWM out on 11 and PFC on 12, so it ain't that. This is probably the same. PFC on 12. Yeah, so it's not on the same pins as ours. It also doesn't have power on 1 either. This has the PFC on 6, so it's not that one. So really, it's just a matter, I'll have a bit of a look around using some of the things I know about this chip and see if I can figure out what it is. And if that doesn't work, I have another plan. I've tried a few different searches now. This one, power factor and PWM controller, SOIC, small outline IC 16, might be helpful, because that's taking me into Mouser, okay? And Mouser is giving me some options, so it just gives me manufacturers. I'm on any, switching frequency any. This is switching for power factor correction ICs. I don't know if they're combined or not. Surface mount. So I have a number here I can have a look down. Let's see if we can find one that might match ours. Well, straight away no, because gate driver's on the wrong pin. Okay. I'll continue searching. Let me see if I can find anything useful. So can we work out what our mystery IC is? Well, maybe. But I'm sure we can figure out enough information to give ourselves a chance. One possibility then, you think, is the easy one, is we have a model number on here. So let's have a look to see if we can find a schematic for NJD9721. And the simple fact is, no, we don't find the schematic on that number. We can try the other one, 3456, that one, sorry, 3546. Let's have a look for that one. And that number, well, it gave me some images, Lenovo and such like, and actually takes me to a YouTube channel, but that appears to be for Lenovo laptops. I don't think that's going to help us any. I don't see any other useful numbers on here, to be quite honest. This is the fire safety rating, that one is. Nothing on the other side of the supply. Well, so far I haven't been able to find it, but what we do have is useful information. We have that. So we know quite a bit about this chip. And this is probably where the swarm intelligence comes in. So I would suggest one of the big forums, badcaps.net is a good place to ask. Electro Tanya maybe, or on a YouTube channel who's doing power supply repair. The chances are somebody watching has some idea what this is, and that's what I'm going to do next. Okay, so at least we have something to ask for. We don't just have, what is that? Yeah, what is that? No, we've done enough work to have some possibility of understanding what the chip is. So guys, let's see if this works in the comments on this one. Yeah, and everybody else who doesn't know, come back in a couple of days and we'll find out. So anybody, any idea what this might be? And if we have an idea, what we can then do is from the data sheet, go back to our PCB and have a look, because we'll have a typical application, if the other pins make some sense. One thing I would like to look for, I haven't seen it, it may be on the other side of the board, is a current sense resistor. There's quite probably a current sense on this. Admittedly, in this instance, I don't actually see one, but if we saw a high wattage resistor on this side, I guess we may have there, or 24 actually. So that could well be a current sense. It looks like a very low value resistor. One end appears to be connected to the negative end of here, which is what you would expect. The other end is here. The problem with this, of course, it will basically read like it's a short to ground. That is effectively connecting directly from the source of this one, the PFC. No, sorry, this is the power supply one. It's connected from the source of here to ground, okay. But there's another track which goes down this way. Again, heading towards our chip. The thing is, this will read like it's ground basically. So one of the pins we saw here that basically read like it was connected to ground could be the current sense, okay? Bear that in mind. So there are other possibilities we can use to go a bit further if we have an idea of what the chip might be. And if we don't, well, you know what, guys, we've done as much as we can here, okay? So I hope you like the technique at least. Let's see if we get a result. And what can I say? Thanks for watching. Let us all know if you have some ideas. And I look forward to seeing you all again soon on Learning Electronics Repair. Ciao for now, guys.